Hi everyone, I'm Bryan. So I am, like mentioned, I'm the sort of lead developer and community manager for Project Northstar, which is an open source augmented reality headset. It's completely 3D printable. You can build it yourself. The only thing you can't build is the electronics, which we currently source from our partner in China. The goal is to create a, fully open source, safe and private AR ecosystem. So that way, when we move towards the future spatial computing, that you can have a computer that you can trust, and really sort of build towards having a ecosystem that, doesn't profit from tracking your every movement or tracking, what you look at, or, isn't able to target ads at you based on, even your gait, which is like the movement in your headset. But, Facebook has openly admitted to being able to track and identify users based on. So there's definitely a ton of open privacy issues in spatial computing that, given our current landscape, really doesn't bode well. So part of Northstar, not only is making an affordable headset that people can actually like build and DIY, it's also sort of about pioneering that private and safe software infrastructure as well for that kind of spatial computing future. In addition to Northstar, I also work at a company called Looking Glass Factory that makes holographic displays. And we currently just launched our second generation of Looking Glass products. So we have the Looking Glass Portrait, 4K and 8K displays now, which are super exciting. Though this talk will be mostly focused on Northstar. So without further ado, I'm going to start sharing my screen here. We can start going over the Northstar project and some of the public information that's out there and how you can sort of get started with your own headset. So I'm going to share my screen here real quickly. All right. So this here is the Northstar website. It is docs.projectnorthstar.org. And this is completely community built as well, which is pretty cool. Myself and other community members on our Discord server, which you can find directly at the top bar of the website, all built this documentation together, which was really neat. So Northstar is a project that was started by Leap Motion back in around June 2018. And it was originally designed to sort of showcase what the potential future could be for hand interactions. And we sort of took that and ran with it. It started building out our own like 3D printed resin lenses, which were pretty bad. And then we've moved towards actually custom injection molded optics, and we were able to source the actual displays that Leap Motion referenced here. So Northstar is the full resolution of Northstar is 2880 by 1600. It uses the same 120 hertz refresh rate displays that the Valve Index uses, and positions them to the side of the user's eye, sort of like this. And what that will allow is a very good stereo overlap effect with also a very high field of view. So Northstar currently, out of the AR headsets on the market, has the highest field of view of any headset. And shown here is me demoing the headset at the MIT Reality Hack last year, right before the pandemic hit. So we had a photographer there who got some really amazing, actually, these are all film shots of Northstar, which is pretty cool. So this was an earlier prototype of it. You can see there's just a Intel T265 on the top, which we're using for 6 degrees of freedom tracking at the time, and then a normal Leap Motion controller. And the design has progressed since then. And you can actually see all of the previous variations on our website here. We have a special section for that sort of go through the releases over time. When the headset was first released by Leap Motion, there was actually no 6 degrees of freedom tracking built in, and people were using vibe trackers and things like that. And moving to inside-out tracking, which is what the Intel T65 provided, and what we will be, we're actually working on our own 6 degrees of freedom tracking system built with a company called Luxonis, has a platform called Depth AI, which is essentially a modular camera based system with an onboard AI learning chip called the Myriad X, which is from Intel. So essentially, we'll be able to build out our own camera system as well, which will make the headset more modular and more open. And sort of it's come up to this point by utilizing components that are already sort of solve some of the problems that we would need to. So, for the prototypes, we use, and we're going to continue to use the leap motion hand tracking since that's the best on the market. But for 6 degrees of freedom, it's nice to be able to have that modularity. And the nice thing about future headsets that are going to use the Depth AI platform is that they'll be able to use full OpenCV algorithms, meaning you can run pretty much whatever you want on board the headset, which is very exciting from a development perspective. So the current generation of the headset, the latest one is called the DeckX. And this is in partnership with a company that we started called Combined Reality, which is sort of what handles all of the hardware manufacturing, sourcing, and distributing. And we actually, so the northstar organization actually exists separate from Combined Reality, so that way there's no conflicts of interest or anything. And both organizations right now are sort of set up with the same guiding principles that we want to create a safe, private, and free open source spatial computing future. So you can see an image of the DeckX here. This can use either the Leap Motion controller or their new stereo IR170 module, which is a bit wider field of view and a bit smaller of a sensor. And this uses currently the Intel T261 sensor, which is a smaller version of the T265 without the metal casing and stuff, which makes the headset much lighter. In addition, the build quality on this is a bit better than previous versions, and it's much easier to print as well. It also has a built-in USB hub, so you can actually run a northstar with just 2 cables, which is actually quite an achievement when you start thinking about bandwidth and everything like that. We're essentially dealing with a full 4K 60 hertz signal, since our displays are 2880 by 1600 at 120 hertz. That's quite a lot of bandwidth to ship over a single cable. So we have a single cable for display and then another cable for power and for data. And given that we currently have 4 camera feeds, we're sending from the headset to the computer. That's quite a lot. And with the Luxartis module, we'll actually be moving that to 5 cameras. So we'll have 2 on the Leap Motion and then 3 on the Depth AI module. So we'll be adding an RGB camera to the middle as well, which will be really nice for pass-through video and things like that. And also doing like machine learning things like plane recognition and everything. As far as feature sets go, in our general FAQ, we sort of go through a lot of like the system specs and everything. We have a nice little handy cheat sheet here for how northstar compares to other AR headsets on the market. So, we do have full 6 degrees of freedom tracking. We have hand tracking. We actually have support for Steam VR as well, though that is in beta currently. We currently don't have plane tracking. So that's like the detection of surfaces. We don't have, but we are working on that. We do have spatial anchors, meaning that like if you leave your room and come back to it, your device will be able to relocalize and remember where it was. In addition, we also don't have light estimation, environment probes, or face tracking yet. Those are all areas of research currently that are rather complex. If you're interested in something that can do room meshing or environment reconstruction, you can combine your northstar with a Z Mini sensor from a company called Stereo Labs, and that will allow you to sort of hook into their meshing algorithms. This is something we've looked into recently, but there are a few issues with just getting that software actually, or not the Z Mini software, but getting an open source version of room reconstruction is actually very, very difficult. It's a very hard problem to solve. And we do have 2D image tracking through Abruco markers as well. And then one other thing right now is we don't have speech input, though in theory here you can actually use whatever speech input is provided by your operating system. We do offer, or we are going to offer a small 4-inch by 4-inch by 2-ish inch compute packs that are actually sort of belt-based, sort of like the Magic Leap. And you can run whatever operating system you want on that, whether it be Linux or Windows right now. Those are the 2 operating systems we currently fully support. And to sort of build off of that, on Windows, we support Steam VR, and we have a custom XR runtime called Esky, which currently works with Unity and Unreal Engine. And Steam VR will sort of handle everything else for now. And eventually, we're going to have feature parity between them. On Linux, we support a open source runtime called Monado, meaning that the entire stack on Linux is completely open, save for the Leap Motion controller hand tracking. That's the only closed source component of our entire software stack right now. And then for lenses and electronic components, everything, you can currently go to smart-prototyping.com and you'll be able to purchase those kits. They're currently on back order as we work through some sourcing delays that are facing the whole world right now, since there is a sort of a global silicon shortage. We've had to replace quite a few parts on our electronics. So moving on, sort of if you're looking to build this headset yourself, we do have a full bill of materials that you can get all these on smart prototyping in like a single kit. But if you wanted to go around smart prototyping and just buy the parts yourself, you can do that. McMaster-Carr has quite a few of these parts. And then we also have a full image focused assembly guide as well. So you can see here that you can actually go through, and we've done essentially a full iFixit teardown guide, but in reverse for the headset. So you can actually go through and see how to assemble the whole thing. One of the more recent additions we did was we released a version of the headset that actually doesn't need these the heat set inserts you can see here. So these inserts essentially make the headset a bit stronger. But some people aren't comfortable with soldering irons or anything, or actually putting them in their prints. So we've released a new set of files that, in addition to the heat set insert version, just don't require them. So there are a few trade-offs of that. You can't, with the heat set inserts, you can disassemble and reassemble the headset essentially as many times as you like, because you're not like degrading the quality of the actual part. But when you're threading into the actual 3D print itself, eventually you will strip out those holes and you may have to replace that part. So that's sort of the main advantage of those. And we've built quite a few custom components as far as USB adapters and power filters as well. There's a lot of like small little things you learn about electronics through this project that, especially with high resolution displays that are very fast, 120 hertz, you need a very stable and clean power source for that. So you can see on our guide here, we have custom connections for the leap motion, and then we'll also go through, how to install the displays. And the most difficult part previously was actually removing the ribbon cable from the displays here. You can see that it's sort of glued to the back, and you sort of had, in previous versions, you had to peel it up. One of the more recent additions we've made were extension cables. So you can actually, you no longer have to do this step. You can just plug the extension cable directly in and run that up to the driver board, which actually handles the display connections. And that should be in one of these steps below. This is the integrator board here. This is what handles all of the USB traffic and provides power to the driver board. And you can see the driver board in this image here. It's the green PCB that's already installed on the headset there. So that is what currently runs and handles all of the display signaling and everything, which is very, very complex. So currently we're the only open source option on the market for this kind of a system, which is pretty neat. And then, going forward, it's pretty simple. It's kind of like a bit more complex Legos, but we've tried to do everything we can to really make the assembly process straightforward and easily documented. So with that, there's also the problem of headgear, right? So we've actually designed our own headgear system as well. And there have been a lot of experiments in the community. This is a pretty good solution for people who want to actually build their own, but you can also, welding headgears tend to be very, very good at holding, like the headset's about 250 grams or so, holding about that much weight on the front of your head. So we either recommend, the 3D printed headgear here, or getting a specific welding headgear that we recommend on our Discord server currently. And if you're curious about the previous versions of the headset, you can actually go to the previous releases, which are all present on the documentation site. You can see some of the differences the design went through originally. And we can sort of have a description of like how this is the original headset that was as released from Leap Motion. And there are quite a lot of changes that have gone through that. This even explains how the combiners work and everything, and then everything is open source on GitHub as well. So if you want to build your own variant of the headset or something like that, you definitely can. And here's an example of it using some welding headgear. that, sort of doesn't reinvent the wheel, right? Like it's nice to, as much as we want to design everything ourselves and make everything 3D printable, there are some situations where it just makes more sense to use an existing solution. And you can see some different variants here as well. We also link all the screws and everything. So, it's a pretty well documented system. We've spent a lot of effort going through it and making this, a repository of all the knowledge we learned as we built this project out. Moving on to our software, like I mentioned previously, we have a few different methods. Esky is sort of our most user-friendly system. It supports both Unity and Unreal Engine. It supports Unity via the mixed reality toolkit from Microsoft. So it's super easy to set up. It's just like a HoloLens, just like any other VR headset you would use setting up with that system. We also have a bare bones Unity system as well that doesn't incorporate the MRTK or anything outside of Unity, and it's more bare bones if you're using for testing. But for new developers, we definitely recommend our SD system. And we also support SteamVR in beta. There are a few things there that we need to clean up. SteamVR is kind of a black box. So it's really hard to develop for as far as like hardware interfaces go. And there's just like little things like the headset still shows up as a extended monitor instead of a full HMD like you might be used to with an Oculus or a Vive. And other than that, it's really the idea is like once you get the Leap Motion software and the RealSense software using that sensor installed, that everything will quote unquote just work. And we've put a lot of effort into making sure that's the case with our platforms. One of the things you'll have to do if you build that yourself is actually calibrate it. And we actually go into quite a lot of detail. This is probably the most difficult part of Northstar currently is actually correcting for the optical distortion in the headset. So typically, if you're getting a reflection from a display, what will happen is that the curvature of the combiner, the optics component, will warp that, right? So if you've ever taken like a fisheye photo, you know that like the lines aren't straight anymore and that it's sort of like stretched. And that's sort of the same thing that happens with an image on Northstar if you don't calibrate it. So essentially what we have to do here is use a set of cameras to figure out how much the image is warping based off of the combiner system or the optics, and then correct for that. So that way the image appears to be corrected. And we have two different methods of that. Our latest version here, you can see on our 2D calibration page, actually uses the same 6 degrees of freedom sensor you're buying with the headset, which is the Intel T261 or T265. Currently is what we recommend. And you'll be able to use that system to essentially calibrate your headset. And then you can, that way you don't have to buy any additional sensors. The 3D calibration method noted here actually requires 2 additional stereo cameras, but does give a much better result than the 2D calibration currently, in that you can actually adjust your interpupillary distance with this method, because it's creating a full 3D solve of the headset versus just a distortion solve of the optics. So that's sort of everything there. We have a full guide on assembling the headset as well, available as a PDF that you can download. And we're also, currently working on documenting the electronics firmware and some of the schematics there as well. That this is a much more complicated thing for us to sort of describe in more layman terms, like we try to. So it's definitely still a work in progress there. You can also find a handful of community links and links to the Leap Motion blogs that sort of started out this project. So yeah, I think at this point, I've talked for a while, so I'm happy to take any questions here. Just tab back over to Zoom and make sure my camera is working. So yeah, happy to take any questions y'all have about the headset or about the project in general. So yeah, I mean, that's a great question. So the first question we got here is, what kind of reaction do we get from commercial AR vendors like the Microsoft HoloLens? And in addition to that, although commercial products seem to have a few additional features in the list, do they see Project Northstar as a threat to their business? So, I don't, it's really interesting because we've actually, had, we've demoed Northstar in the same room as a HoloLens and Magic Leap at the MIT Reality Hack last year, which was right before the pandemic. And what was really interesting is a lot of the developers who tried the HoloLens actually enjoyed the Northstar more because it does give you that wider field of view. We're definitely not really competitors, I would say. If people are interested in the Northstar, or interest, or if people are able to afford a HoloLens, they'll probably buy a Northstar 2 in addition to it, since the HoloLens is so expensive, comparatively. So I don't really think they see us as much competition. We definitely don't sell near the same amount of volume as a HoloLens or a Magic Leap system. Actually, I think we have sold more than Magic Leap, but that was an interesting case with Magic Leap there, since they were much higher priced headsets. And they're sort of solving different problems, right? Like we're going for a larger headset, larger field of view, really good experience, but it's not completely standalone like the HoloLens is. Like the HoloLens is a full unit, all in a headset. And we do have, if you want to have a mobile version of Northstar, you need a compute pack and a battery on your belt. So there are definitely a few differences between the systems. But I would say in this case, they're meant more to coexist with each other rather than compete directly. So, and as far as like open source tools go, Microsoft and these other companies that are spending a lot of money on augmented reality will, have better systems than we do. We are working, hard on, building out those systems and making them have feature parity with these larger companies. But at the end of the day, Facebook, for example, has 20,000 people working in their XR space, and we have about 2,000 people on our Discord, and about 50 of those are developers who actually work on the Northstar platform. Given that we're an open source project and we sell our hardware at a very small margin in order to keep the project sustainable, we don't make a ton of money on it. So we don't really have the budget to hire a bunch of developers to work on this kind of project. We're trying to make it so that way, this headset is affordable for everyone and as accessible as possible. So there's definitely some improvements that we could make as far as software development goes. But if anyone's interested in contributing, that would be absolutely greatly appreciated. There's a lot of really cool things that we could use, like fun demos or anything related to like small UX tweaks, or even changes to typos in the documentation that I may have left in. So there's absolutely room for this project to continue to grow. And I do think as technology progresses on, it will become more of a competitor to these other headsets. But you also have to recognize that the complexity and the technological advancements that these companies can produce is much, much higher than what a DIY headset can be, right? If you look at the Apple AirPods, for example, these things are so small to the point where you cannot build a DIY AirPod, right? That's how small the electronics are. You need like a custom clean room to build those, and like microscopes and everything like that. So that's sort of not really the goal of the Northstar project. So I am open to more questions. I'm happy to give plenty of time to anyone who asks. So if you all have more, please feel free to throw them at me. Doesn't look like we have any yet. So what I'll do in this case is I'll continue sort of going through the Discord in this case and sort of showing you some of the projects that people are working on. So I'm going to share my screen again here, just a moment. All right, so if we go to the Northstar Discord here, so this is our Discord. We've got about 2,000, over 2,000 members in it. I'm the admin there. We have a handful of moderators and other members. Like we have a few people from ultraleap who have joined, who are the company that owns Leap Motion. Lots of students and educators, researchers and developers, and it's really cool seeing people adopt the platform for different uses. And sort of in the showcase channels where you can see most of the recent updates here. And I'm just going to give it a second to load. It seems like my internet isn't doing too well at the moment. Yeah, so it doesn't look like that quite is going to load. But in the showcase channel, you can see a lot of different experiments that people are doing. A lot of people are working with audio right now, which is really cool. So they'll have like an object that plays audio and it'll change as they move closer or interact with it. And then in addition to that, we're using the project to build out a lot of really core features. Like you'll see Oculus have like reprojection, which is essentially where, if your computer can't output enough frames, we will essentially interpolate between them based on the position of the headset, which makes a much smoother experience. One of the things that is very difficult about AR is that, with VR, you have a lot of leeway because you can only see what's in the headset. Whereas with augmented reality, every part of the image has to match up with something in real life. So if there's any discrepancy or any like stutters or other oddities, your brain will pick up on that much more readily than in virtual reality, where there's only one plane of reference, which is the objects. So there's definitely, I think that's probably one of the biggest challenges of augmented reality is trying to get the objects that are in the virtual space to line up exactly with the real world. And you can see here, we have a lot of conversations about text and all that. So if y'all have any other questions after this talk, please feel free to join the Discord and ask them. That's sort of how we learn more, is that we ask each other questions and sort of build off of a shared knowledge base. And even I find, like, as someone who sort of maintains this space, that the more questions that are asked, the more I actually learn, right? Because sometimes people ask a question that I don't know the answer to, and I'll just spend some time going out and researching that and solving some problems there. So if anyone, again, has any questions, like, please feel free to ask. There's quite a lot of there's quite a lot of different parts of this project. And it's definitely an interesting thing. And I can actually show, while I'm still on the Discord here, my actual first Northstar before we were able to source the components. And this is what that looked like. So this was actually a Windows mixed reality headset back when they were selling for $200. I bought one and disassembled it and was able to source some custom cabling and everything like that to essentially rebuild my headset into a Northstar. And I tried repurposing the tracking cameras and everything like that. Unfortunately, this sort of worked. It did display an image, but at the time, since I had taken it apart, the 6 degrees of freedom tracking broke entirely. Microsoft goes through a calibration process to really sync the cameras with the inertial motion unit on the headset. So when I had taken it apart, I completely voided that calibration. The headset had no idea what it was doing, aside from displaying an image there. And then after this first one, I did a second iteration with a Samsung Odyssey headset I was able to pick up off eBay that had a broken lens on it. And, I didn't care about the lenses. I just wanted the screens. So this is a version of that. It's definitely a bit hacky at the time. As I progressed through the project, my 3D printing skills got better than this. But you can see here with the screens on, and the Samsung Odyssey had the same display size as the Valve Index display. So I was able to sort of better take advantage of the field of view. This is with an early prototype of the combiners that we've since improved the actual coding process on to make it more reflective and make the image brighter. So there's definitely a lot of continued progress that has happened. And here's a quick video of that system. So you can see this is actually the Windows Mixed Reality Home. It's upside down in in that version of the headset, which is much more transparent than the current version. I'm going to see if the showcase channel here has loaded at all. And yeah, it looks like it has. So here is a video tutorial, or not tutorial really, a video showcase of what a user currently sees through the headset.
Got some spatial audio working here.
Looks like this sort of isn't loading here. That's okay though. We'll forget about that then. I'm going to pop back over to the Zoom and see if we've received any other questions. Looks like we have. Yeah, so it's definitely a balance of creativity and learning, right? Like there's a lot of things that you have to innovate on or figure out throughout the development of a hardware project that you might not learn otherwise. Like when I started the project, I have a background in architecture for buildings, not for computers or anything like that. So, I picked this up because I was interested in and I was like, oh, it's neat that you can 3D print it and build it yourself. I'm going to try it. My office at the time had a 3D printer in the back that no one was using, so I sort of commandeered that and started printing headsets for fun. I learned about 3D printing and how it actually works. And then I learned about electronics as I had to sort of investigate like how to build my own cables and get those all manufactured. So there's absolutely I would say northstar is one of the best learning opportunities out there. Especially now that you can build off of a community's worth of research, right? Like we've done all of the hard work, sourcing all the electronics now, and a lot of the problems have been solved already. So, if you're looking to either learn more about the solutions we've already solved or the ones that we're planning on solving, it's a great time to join in, right? Like we no longer have issues with figuring out what hardware to use or anything like that. Like that's all sort of solved for you. So it's going to get more and more polished as time goes on. And it'll be really interesting to see, what the state of AR is in the future as well. And eventually Apple will come out with the headset. Facebook's been working on the headset behind the scenes. Microsoft will continue to develop on the HoloLens, and Magic Leap does still exist. So there are quite a few other players in the space. So it'll be very interesting to see, what the future of northstar holds, given the changing technology landscape, right? So it's always full of interesting problems to solve. And one of the things that's important for us is to position northstar not only as a product, but also as a opportunity for people to learn and build their own skill set. The reason I have my job currently at Looking Glass Factory is because of all the work I did on northstar, and I was able to leverage that, put it in my resume, and show like, hey, like I can do this stuff, right? I have a degree in architecture for buildings again, but I've shown that I can do development, and I can do electronics and software and community management. And that's really what landed me my job at Looking Glass. So I was super, it's definitely helped me in my career, and we've also been able to position or get a few people in the northstar community positions at other companies. Like one of our developers, Moses Turner, recently got a position at Collabora through an internship there. And that was through his work that he did on the northstar headset. So there's quite a lot of different avenues for people to go from northstar into something more tech-based or anything like that. So if anyone's looking for opportunity to sort of kickstart their career in an interesting space, while northstar.org isn't really hiring right now, of course, because it's, as I mentioned before, we're not a for-profit company at all. We're absolutely here to help mentor and help teach people about this project and about electronics, 3D printing, software engineering, and hardware engineering, right? So there's absolutely opportunity for new folks to join in and learn and start building this project with us. So I think with that, I'm sort of out of words to say, unless y'all have more prompts for me. So Yeah. Anyone else have some questions for me to answer?
Yeah, if you guys have any questions, put it in the Q&A. We can answer those.
Cool. Looks like we
How
got
do we
one.
learn more about electronics and hardware?
Sure. So it's a really, really good question. And I would say the best way to do it right now is to start looking into microelectronics, like a company called Adafruit. Essentially sells a lot of little kits that you can play around with like RGB lighting and Bluetooth and things like that. And they have a ton of resources on just getting started with pre-built microcontrollers and they'll teach you how to solder things and how that works. And then as you get more experience with the sort of pre-built systems and things that you can sort of DIY together that are sort of built for learning, you can start using what you've learned on those systems to further develop your own systems. What I will say is that nothing is easy, right? It's all going to take effort and time, and it's going to feel really confusing at some point. You're going to see like math formulas that you just like don't even think are real. There's a lot of complexities, right? Like one of the big problems with Northstar originally was that like the traces for the display signal, so that's the actual lines that the data is going along the circuit board, had to be exactly the same length for every single trace. And there's about, I'd say, 100 traces just for the display signals on that circuit board. So maneuvering the circuit so that way the line is the same distance for each individual trace on the circuit board was very difficult to engineer. It's like stuff like that seem like common knowledge are really sort of obfuscated through a lot of different things. But I would say definitely looking into Adafruit or SparkFun, sort of get started with electronics kits and everything, and then from there, if you're looking at building your own circuits or anything like that, I would say that's a great foundation. In addition, there's a bunch of resources on YouTube or Skillshare that will sort of teach you more about that topic. But you can also ask people in the Northstar Discord. Of course, that's always helpful. But there's it's always good to sort of educate yourself a little bit before going in and asking experts something, right? Like you wouldn't want to ask like an expert mathematician how to do addition, right? So there's a little bit there. But that being said, there are also no dumb questions, right? So if you are struggling with something or just can't seem to figure something out, asking people is really one of the best things you can do to further your learning.
Thank you for the answer, Brian. By the way, all of these links will be in the event description under a link saying additional resources. So if any of the attendees want to see that, it'll be there. May asked, have you built a Raspberry Pi before? May, do you mean like have you used a Raspberry Pi or like tried to replicate one?
Yes, that question is a little bit different. We have actually, yeah. So replicating one's sort of not worth it, right? People have already solved that problem. What I would recommend instead is building off of the Raspberry Pi platform, and we've actually done that with a very early version of the Northstar headset before we were able to source the higher resolution displays. We had a Raspberry Pi or a version of the headset that ran off of Raspberry Pi displays that was super low resolution and very hacky. But did actually work, and it was very low cost, right? Those displays are about, $30-ish each. So, at the time we had a headset for under $100. It was very low quality, low refresh rate, low brightness. But, that was sort of the first foray into the project for people who, didn't have a ton of money to spend on it. So I would say instead of trying to replicate a Raspberry Pi or rebuild one yourself, I would definitely recommend using or building off of that work that others have done. And it looks like there's another question here. So this one says, when designing the AR headset and considering components to use in it, how do you deal with the issue of serviceability and reliability to extend the useful life while trying to keep the manufacturing cost manageable? And that's a great question. One of the things we're currently doing in our hardware design is actually making some of the harder to source components modular, in that you can actually, if you're familiar with building a PC, the storage is on like an M.2 card and the graphics card is a separate part. We're trying to build out a similar system for augmented reality, where in this case, all the cameras are connected via USB ribbon connectors. So, if you want to upgrade your cameras later, or there's like a newer version of the Leap version, you can swap them out and plug them in via USB directly to the headset. In addition to that, you'll be able to swap out the displays on a new driver board with other displays as they come out. The problems with those are many, in that like you can't just like plug in a new display, right? It's not like a normal computer monitor. You actually have to write firmware, which is software that goes directly on the circuit board itself that tells the software how to adjust the specific timings for the display and adjust what the resolution is for each specific display you plug in. So it's a bit more complex than just plugging in a new monitor. But our goal is, as new display panels come out and new technology comes out, we'll be able to update the headset to better suit that. Or as like microcontrollers that support DisplayPort 2.0 versus DisplayPort 1.4 come out, we'll be able to essentially take a similar to an M.2 card and take out the existing chip and put in a new one. And that'll help us a lot as well with the current manufacturing crisis that's sort of going on in the world, where there's just a global supply chain shortage of many electronic components. So the idea is like, not only for users will be able to upgrade their headsets, but if we need to swap out a component that's no longer available, we can do that without redesigning an entirely new board. So there's absolutely considerations to make for reliability and serviceability. And I think the main thing we're doing towards that is making sure that the core components are detachable and you can use whatever sensor you want, right? In fact, you don't even need to use a leap motion with the headset if you don't want to. We recommend it, and it's especially since leap motion started the project. For us to remove it would be sort of a bad faith kind of deal. But it's absolutely not required if you can't afford it or choose to go a different route. We're not going to force you to use it. But we're definitely going to continue to integrate those components and software. So I hope that answers your question there. It's definitely to go into the manufacturing cost of it. There's obviously choices to make there, right? There's a lot of features that we've wanted to add, like eye tracking or eye position adjustment that we haven't been able to because those parts are just very expensive. The sort of what we're moving more towards is like we're going to give people the ability to add those parts, the ability to add on those options without requiring them. And I think that's sort of where I see northstar moving to, is like there's a more modular system where you can even pick your own cameras you want to run. If you want to run 3 RGB cameras instead of 2 monochromes and 1 RGB, you can do that. And it'll require a bit more work and a bit more effort, but the possibilities will be there. So with that, I've got time for about one more question if anyone wants to ask it before I have to leave. But I really enjoyed answering these questions. I think they were really fun, and I hope you all have a great time. Yeah, awesome.
Thank you so much for spending all this time with us, Bryan. I really appreciate it on behalf of everyone at Labs. Thank you.
Of course.
It was very
Yeah, it was a
educational
blast.
and very helpful. Thank you. All right. I believe that's all the questions we have, right? Yeah. Okay. Thank you again for your time.
Of course.
And have a good day, everyone. Thank you.
Great. See y'all.
Bye.